Okay, section 41 is entitled Proportion Problems. You want to know if two proportions are equal to one another. For example, 4 to 10, is this the same as 8 to 20? In other words, I'm no cook, but if four cups of sugar go in 10 pies, is that the same as, is it the same proportion as 8 cups of sugar? It sounds like a lot of cups go into 20 pies. Are these the same? Is 4 over 10, are they the same proportion? Is 4 over 10 equal to 8 over 20? And the way to do this is you cross multiply. Now since the 4 is on the top, I put the product on the left where the 4 is. 4 times 20. Does it equal to 10 times 8? Since the 8 is on the top and is on the right side, I put the 10 times 8 on the right side. That is 80. 4 times 20 is 80. Does that equal to 10 times 8? And yes, it does. That means they're all equal. They're the same proportion. Is 2 over 3 the same proportion as 10 over 14? 2 times 14, does it equal to 3 times 10? Is that true? Is 28, well, 3 times 10. Does 28 equal 30? The answer is no. So they're all no. They're all not true. So 2/3 is not the same as 10 over 14. Is 6 over 11 the same as 18 over 33? And there's a couple of ways of doing this. 6 over 11 is equal to 6 over 11 times 1. Now, you may say, I want to get 18 on top. I know 6 times 3 is 18. So this has to be 1, so 3 goes on the bottom. Oh yeah, 11 times 3 is 33. They are equal. Or if you prefer, you could have said, you know what? I know that 11 times 3 is 33. And I can only multiply the 6 over 11 by 1. Because 6 over 11 times 1 equals 6 over 11. You have to be an expert in multiplying by 1. And if this fraction is 1, the top has to be the same as the bottom. And 6 times 3 is 18, and yes, they are equal. If you didn't like that, you can cross multiply. If 6 times 33 equals to 18 times 11, if you worked it out, they both equal to 198. So they're all equal. Yes, the proportions are the same. The same proportion. Is 10 over 2 the same as 5? That is 5 over 1. It is 5. Is it the same as 5 over 1? Well, it is 5. Well, 2 times 5 should equal 10, and it does. So yes, they are the same proportion. If 10 pizza pies are going to go to 2 people, that's the same as, on average, is 5 pies per 1 people, or 1 person. 10 pies per for 2 people. That's the same as 5 pies for 1 person. Maybe the pies are rather small, okay? So if you go into our store and it says 10 pies are for 2 people, and you're just 1 person, you'll say, give me 5 pies, please. The small pies. That's enough for 1 person. Okay. And that's a very important rule that I stated over here, that the denominator times the other side should equal the numerator. You should know this like you know your name. For example, somebody says, what number divided by 4 is 7? Your teacher is going to say multiply both sides by 4. To me, that's not so bad, but you don't need to do that. 4 times 7, 28, is that number. X is 28. Done. It's done. If you were asked what number divided by 3 is 9, done. 3 times 9 is that number, which 3 times 9 is 27. X must be 27. It is 27 divided by 3 is 9. I know that's true. 3 times 9 is 27. Know that pattern like you know your name. Okay. The next thing I want to talk about, and it really puzzles me, that teachers would teach students to cross multiply. There are students who, if they only learned one thing in their math class, it's to cross multiply. And that's a disaster, because cross multiplication is very inefficient. The only time you should cross multiply is if you knew that number. That is 3 over 4 the same as 6 over 8. Yeah, 24 is equal to 24. 8 times 3 is equal to 4 times 6. Now, visually speaking, so let me just write it down over here. What is in the way of you knowing what x equals? And the answer is the 4. If the 4 wasn't there, and a division on it. If you got rid of the 4, you know what x equals. X equals, in this case it says 6 over 8. But the 4 is in the way. Now, if you cross multiply it, you would have 8x is equal to 4 times 6. Now, you must admit, you got rid of the 4. The 4 is no longer there. But the 8 is there. You may say, well, that's fine. The 8 comes up there. So now, the very next step is to get rid of the 8. To put the 8 right back where it was. That is, x is 24 over 8, which is fine, 3. But my question is, why bring the 8 up there if you're just going to bring it back down the next step? Okay, if you were a boss, you're in a company, and you have this worker, and you tell the worker to go to point A, and then go to point B, and then come back. And that worker, no matter what you tell that worker to do, it goes to C, and then it does what you want, and then it comes back. It comes back here, and then it goes to A, and to B, and back. That is, it always goes to C and comes back. Possibly C is the water fountain. Well, I definitely think people should be able to take a water break, but in terms of just the boss, this is not good. You can't do this. This is inefficient. No matter what you're told to do, you walk around the block 3 times, and then you do what you're told to do. That's inefficient. You're not a good worker. Well, bringing the 8 down, bringing the 8 up, and then putting it back down couldn't be any more inefficient. cross multiplication should never be mentioned. The only time I ever mention cross multiplication is when I want to see if two fractions are equal to one another, which is the same as are two proportions equal to one another. Now we are definitely digressing a little bit by talking about proportions with unknowns, but the way you do this, if you want to say cross multiply, if you want to use that, do half cross multiplication. Just bring the 4 up there. Don't bring the 8 up. That is 6 times 4 over 8. 4 goes into both of these numbers 1 and 2 times, and 2 goes into both of these numbers 1 time and 3 times. And you get 3. Or you can say 24 over 8 is 3. Don't cross multiply. It's completely inefficient. It couldn't be any more inefficient. If you have x over 7 is 6 over 21. I'd rather not write over the problem, so I'll write it down again. Just do half cross multiplication. Bring this 7 up there. Don't move the 21. And then you say 7 goes into 21 3 times. And 6 divided by 3, why that's 2. So x is 2. 2 over 7 is 6 over 21. And that's true, because 7 times 6 is 42, and 21 times 2 is 42. Just do half cross multiplication. Do not cross multiply ever. Should never cross multiply. It's the most inefficient rule I've ever seen. Ever. If you're given x over 8 is equal to 12 over 2. That is, what's the proportion? What should it be? And first of all, I would just say this is 6. 8 times 6 is equal to x. Done. Okay, if you have x over 8 is equal to 13 over 2, do half cross multiplication. Bring the 8 up. Don't bring the 2 up. Why? Because next step you're going to bring it right back down. That's completely inefficient. 2 goes into 8 4 times. 13 times 4, 52. Okay, the next thing I want to show you, and since there's always two fractions, you can always say this is proportions. We know that 2 over 3 is equal to 2 over 3. Well, if you choose the reciprocals, they're equal. If two quantities are given to be equal, that is, they have that equal sign in between them, then their reciprocals are equal. If somebody tells you that 1 over x is 2/3, well, you can't argue. This and this, they're equal. I mean, if somebody tells you 2 over 3 is equal to 2 over 5, you can say, no, it's not. But if I don't tell you what x is, they're equal. You can figure out what x is. Take the reciprocal of this. You get x over 1. The rule for dividing by 1 is don't do it. It's just x. Take the reciprocal of the other side, you get 3 over 2. That's what x equals. That's what x equals. That is copying this with my answer for x. 1 divided by x. We claim it's 2/3. Well, let's see if we're right. In division, if one or both of these are fractions, use the following rule. And one of them is keep the top number the same, change division to multiplication, flip over the second number. 1 times 2/3 is 2/3. That is 1 divided by this number is 2/3. This is asking 1 divided by what number is 2/3? Answer, 3/2. If I tell you 1/x is 7/9, flip this over, just get x. Flip over the other side, get 9/7. You don't have to cross multiply. It's so much easier to just take reciprocal. Now what if it isn't 1/x? What if it's 3/x? Much, much harder. Or is it? You have 3/x, and I tell you it equals to 7/11, you take the reciprocals of both sides. The reason I'm doing that is to get x in the numerator. Don't ask me why this didn't right. Sorry. If 3/x equals 7/11, I take the reciprocal of this and I get x/3. I take the reciprocal of that, I get 11/7, and I say they're equal. So we have x/3 equals 11/7. Half cross multiplication. Just bring up the 3. And 7 and 3 doesn't reduce, so it's 11 times 3, 33/7. Problem is done. One more. If you're told that 4/x is 6/15, how do you find out x is 10? Well, you can cross multiply, but that's a disaster. Why not just take reciprocals? And then bring the 4 up. Now you can reduce, or you can say 15 times 4 is 60 over 6 is the answer I said, 10. That is 4/10 is 6/15. Now if I wanted to check that, I could cross multiply. 10 times 6 is 60. 4 times 15 is 60. Yeah, 4/10 is 6/15. In fact, that's how I would check that problem. If you tell me the answer to this is 10, how would I check it? I would cross multiply. That's the only time I would cross multiply. And there's even ways where you don't have to cross multiply. But it is the easiest to do to see if two fractions are equal. Okay, that completes the section on proportion problems.